Okay, before we start doing our multi-step inequalities, we need to go over some basic rules and stuff to make sure we remember these and the symbols. So this symbol right here is greater than. So this says x is greater than 3. Well, when we graph this on a number line, think about this. If I substitute 3 in, 3 is not greater than 3. So 3 is not a solution. So that's your starting point or your boundary. And then you're going to shade all the solutions, anything that's greater than 3. Okay? So the next number would be 4. I could actually put that in there, and I would make that inequality true. This symbol is less than, so this one is saying x is less than 3. Again, 3 cannot be a solution, but that is my starting point. But every single number on this line that's shaded, x represents. So x could be 2, 1, 0, all of these numbers on that shaded part of that line, but it cannot be 3. So notice these two, you're using an open circle, because that means it's not part of the solution. On this one, this is greater than or equal to. So because there's a line under here and it's equal to, I'm going to shade that circle in. That means I can say 3, which makes it true, is greater than or equal to 3. So x represents all the numbers from 3 and everything above. This one here is less than or equal to, let me put my inequality in there, x is less than or equal to 3. So we're going to start with a closed circle at 3, which means 3 can be substituted in here. 3 is less than or equal to 3. So we're going to shade it in. And all of these numbers that I'm shading in are solutions as well. Okay? Okay, the next thing we need to look at is, you need to know that these two are the same. This one says x is less than 2, or 2 is greater than x. And then this one says x is less than or equal to 2, or 2 is greater than or equal to x. So think about this one, okay? Let's go back to this one right here. X is less than 2. Notice it's pointing at the x. It's still pointing at the x over here. We just put it on the other side of the inequality symbol. And this one here, this one's x is less than or equal to 2. Notice it's pointing at the x. It's still pointing at the x there, okay? And this one would be graphed as, let me put my number line here. So x is less than 2, so it would be an open circle at 2. And all of these are solutions, okay? And the way you test this is, let's say, okay, let's say 0 is shaded, right? If I put 0 in here, it's going to say 0 is less than 2. And if I put 0 in here, it's saying 2 is greater than 0, okay? Like this one also. We're going to graph this one. So it says x is less than or equal to 2. So shade, closed circle, and every single one of these. So I can take 0 is shaded, I can substitute it in here, 0 is less than or equal to 2, and I can substitute here 0, and it says 0 is greater than or equal to, 2 is greater than or equal to 0. Okay, so now we're going to start solving them, graphing them, and then you need to know some notations. So just like equations, we want to get x by itself. So we're going to subtract 2 from both sides. That cancels. It's greater than or equal to 4. Let's draw our number line. And I'm going to make that 4 and that negative 4. So if it's greater than or equal to 4, that means this is my boundary right here. Since 4 is included, and everything that's going to represent x has to be larger than 4, so it's greater than or equal to 4. The next thing you need to learn is, we'll go over set notation first. Okay, there's different ways to write it, but we're going to take the shorter way. So you're going to use those symbols, and you're going to say x. This line right here means such that, and then you just copy your inequality. and this is called a solution set. These mean set notation, okay? Interval notation is you're going to look at your graph, and so think about this. We're starting right here. We're going to use this symbol if the circle is closed. So we're starting at 4, and then you're going to infinity. And then, anytime you use infinity, you use parentheses. Okay, let's try another one. So we're going to subtract 3 from both sides. Okay, so now we're going to graph it. So we're going to do an open circle at 2, which means 2 is not a solution. And all the solutions, the value of x, are going to be every single number less than that 2. So now we're going to do set notation. Oops, I spelled that incorrectly. Okay, so we're going to say x such that x is less than 2. And now, this is the infinity, a negative infinity on this side, right? So for interval, remember I said we use parentheses for interval. So parentheses in this graph is going to negative infinity, and it's going and going and going and going, and it's stopping at 2. Well, when the circle is open, we use parentheses. The only time we're going to use this symbol right here is when it's closed. And you never use it on infinity or negative infinity. Okay, so it looks a little different, but let's start working on it. So we're going to subtract 15 from both sides. We have a negative x is less than negative 8. We're going to divide. We can't have a negative x even when we solve inequalities, right? We're going to divide this by negative 1. Some people say you can multiply by negative 1 either way, because we want to eliminate that negative sign. And when you multiply or divide by a negative, right, which we did, this inequality symbol has to be reversed. And that's a rule you have to remember. Now let's graph it. 8, negative 8. Okay, it's going to be an open circle because it's not included in the solution. And everything above that is a solution. We're going to go to set notation, and then I'm going to discuss why we reverse that. Set notation is x such that x is greater than 8. And now we're going to do the interval notation. So we're going to look at our graph. It starts at 8. It's not a closed circle, so we're going to use parentheses. And then it goes to infinity, positive infinity, and we only use the parentheses for the infinity. Okay, let's do another one. So the next one's going to be 2/3 x plus 3 is greater than or equal to 11. So we're going to subtract 3 from both sides. Bring down our 2/3 x, cancels. Remember, we want to do the reciprocal, multiplied by the reciprocal. That cancels. And x is greater than or equal to 12. So we're going to graph it on the number line. And now this time we're going to check our answer too. So greater than or equal to 12. Sorry. Okay, so now we're saying all the x values are greater than or equal to 12. There's a couple ways you can check this, but when you check it, you're always going to put it in the original equation. Okay? So I'm going to check it. So the next number would be 13, right? I'm not going to do this 12 just because I shaded it in. It will work. But I'm going to try 13. 13 will be my next number. So, and I'll show you two different ways to do this. 2/3 times 13 plus 3 is supposed to be greater than or equal to 11. Okay? So 2/3 times 13, this is 26 over 3 plus 3. Okay, so 26 divided by 3 plus 3 is greater than or equal to 11. So you can put this in your calculator. And when you put this in your calculator, you're going to get 11.6 repeating. Okay? Which, this is true, so I know I shaded it in the right direction because anything that's shaded is the solution. The other way you can do this is you can use the 0 as a test point. Notice 0 is not shaded. 0 is not shaded. So if I substitute in 0, this is not true, right? So I don't want to shade 0. That's just proof that I don't shade it. Okay, so we still want to do our set notation. So we use the brackets, and we're going to say x such that x is greater than or equal to 12. And then our interval notation, we start at 12 and 12 is included. We're going from left to right. And then it's going to infinity, and we never use, we only use parentheses for the infinity and negative infinity. Okay, now we're getting into the multi-step. And we know how to do multi-step equations, so we can do these too. So we're going to do x plus 3 is less than or equal to, distribute. Now I'm going to move my variable over. And then I'm going to add 8. And I get 11 is less than or equal to x. We are going to leave it like that. I know sometimes people are saying, always have the x on the left-hand side. And we're leaving it that way because you have to know how to graph this as well, too. Okay? When it looks like that. Because it's not always going to be perfect. So there's there's 11. And there's negative 11. So there's my line there. So now we know we have, let's think about this. We know we have a closed circle at 11. Okay? Closed circle at 11. Well, can I put 0 in for this? Let's look at that. Let's say, if we shade this way, that means 0 is going to go here. And this is saying 11 is less than or equal to 0. That's not true. So we're not going to shade the 0. We're not going to shade in the direction of 0. We're going to shade the other way. And then let's just check it. The next number would be 12. If I put 12 in here, would that make that inequality true? Absolutely. Saying 11 is less than or equal to 12. Okay? So we know it's correct. Okay, we're going to do our set notation. So we're going to say x such that, and we can put it just like it is. A lot of people will put the x first. And that's good. And then we'll do our interval. So the graph starts at 11, and 11 is included, so we're going to use that. 11 and infinity. Okay, one more problem. Negative x plus 6 is greater than, there's a negative sign on the outside, 2x plus 4. Okay? So we're going to be on negative x plus 6 is greater than, distribute this negative sign, negative 2x, negative 4. Okay? Let's add this 2x to the other side, so we don't have a negative variable. That's going to give me x plus 6 is greater than negative 4. And don't forget, when you multiply or divide by negative, I'm just reminding you, it's not in this one, but if you